Hi everyone, I'm Stephen and welcome to Audio Nautica. This is part 3 of my Marantz 7 clone build, and this video will be about the input selection circuitry. So just to show you where I'm at the moment, I've done some internal work on the enclosure that relates to this. So this is the input selection switch here. So this is the harness that goes to the input selector board. So I've just tacked this connector in here just at the moment so that I could get this all worked out. So basically this just switches to ground. 4 wires here, one of these is ground, so this will turn on the appropriate relay for when the input selector is chosen. Now I've also made a bit of a modification. So FB, who this is for, requested LEDs on the front panel to show which input was on. So that's these 4 LEDs here. So I found these JST connectors at JCar that just slide on the back of the leads, just cut them shorter. So this is a common anode. And then I've just run over to here. There's another set of contacts on this switch that wasn't actually used. So doing it this way, it means that so the common is connected to ground, so on the other set of contacts, so it runs back through this ribbon cable, and so basically it just will switch the supply through to the switch the ground for the appropriate LED, so that as you change the input, the correct LED will come in. So basically what this meant is that coming away from this, I only need one extra wire, and that will just go to one of these resistor feeds as to where these LEDs, so the board allows for actually 5 LEDs because there are 5 relays, but I won't be fitting those, and I'll just be running this to one of the LEDs, or one of the resistors, series resistors. One of the LEDs is only ever on at once in this particular configuration, so I don't need to fit the other ones. So basically that's the plan there. Let's turn it around here so we can see. So these are the input harnesses for the inputs, so they'll get wired up later. So yeah, it's kind of time now to dive in and build this input selector board. Okay guys, here's the schematic for this input selector board. It's very simple. It's basically just a bunch of relays that, as I mentioned before, they're switched to ground to enable the relay. There is facility for an LED, which is just connected across the coil. So as I mentioned, I'm changing that arrangement. There's a 5-volt regulator here, so these are 5-volt relays, and that's about all there is to it really. So again, the instructions fairly vague. They basically say build the board using the schematic diagram and using the bill of materials. So this is a very simple design, so we'll get into this. Now I normally do say to start with the lowest part and work your way up. I've got this connector tacked in. I don't think I'm actually going to need to take that out, so I'm just going to leave that in there and just make a start. So these are the diodes that go across the coils of the relays. So we get those in there. Just check that against the schematic. Can't actually read the designators because they've gone and shoved some text on top of the designator, so I can't even read it on the schematics, but anyway, you get that. Bend these so they don't fall out. So let's get these in. That's those ones in. Let's give them the old snipperoo. And once again, I just like to give these a reflow after the snip. It just gives them, just makes the joints a bit neater. Being careful not to reflow my thumb, because that would hurt. Okay. Now there's actually very few discretes on this. So there's these resistors, but I'm actually only fitting 2 of them because these are the series current limiting resistors for these LEDs, and I'm not actually fitting these LEDs. So the purpose of these 2 resistors that I'm fitting, one of them will be the feed to the LEDs on the front panel, so there's only ever one of them on at any one time, so I only need the one resistor. And the other one is probably going to be the power LED. I have installed the power LED, but it needs to get power somewhere to make it glow, and I'm thinking this is probably as good a place as anywhere to pick that power up. And if I change my mind, well, having this one little resistor installed in here, not used, is not going to be the end of the world. Okily dokily. So I'm just going to finish soldering in this inline connector, there's really not very much. The annular ring on these pads is very, very small. Which means it is quite tricky to get the joint just the way that I'd like it to be. Okay. Not brilliant, but acceptable. Right. So, now we've got this 7805, and again, I really have absolutely no idea why. I saw the same thing on the timer delay board, that they've provided this electrical insulation mat, but as far as I can see, there's nothing to insulate from. So I really have no idea why this is here, but it's in the kit, so we might as well put it in. Come on, Mr. Nut. Do your thing. There we go. Okay, that's good. And I'm just going to switch over to my chisel tip now, because I'm going to need the extra heat. Nice. Okay. So next we've got these two electrolytic capacitors. They're Nichicons, so they're a nice brand, but the footprint is kind of a bit small. Shall we get them around the right way? Ground in the middle. So they're just a bit too close to sit together neatly, so they'll just might have to sit like that. Yeah, the footprint looks like it's for a tantalum, but the bill of materials says that they're 100 mite 50 volt electrolytics, which is what they are. because these two pads are so close together, they tend to bridge over. I mean, I could unbridge it if I wanted to, but I'm not going to. But it's not the best design in terms of the board layout, because you get that funny joint, which I would suspect Mr. IPC would have something to say about, but there you go. Okay, so I just want to make sure that I don't have a clearance problem here. Yeah, we'll be okay. Just. Alright, so I think we can now whack these relays in. Just going to see if I can possibly, can I get lucky and whack them all in, and can I work out a way to flip the board without them falling out so that I don't have to solder them in one at a time. Oh, have we done it? Have we done it? I think we have. Okay. So what I'm going to do, careful. I'm just going to tack each one in. So 2 pins on each one. And then that way I can check the alignment. Some of them don't look like they're sticking through very far to me, so they might be caught up on something, or maybe if one of them is sitting up a bit more than the others, it could just be holding them up. So I'll just tap them in so they won't fall out, but I can then easily fix up anyone that needs to be fixed up. Okay, there we go. Now let's see. Okay. No, they're all... Okay, they looked like they looked right, but by feel, so if I do it this way you should be able to see better, guys, but I'm doing it with feel. I've got the finger behind, and as I reflow the joint, there, I could feel it pressing onto the board. There. That's better. So now that I know that they are all in the right position, I can dial in and solder them in. Okay, there we are. Nice. So all that is left now is these connectors. That's right, I forgot about that, didn't I? They're actually lower than the relays, which means they'll just fall out. That one's not, because it's jammed up against some parts. But it doesn't matter. Where there is a will, there is a way. Oops, it just fell out. So I'll show you the will in just 1 second when I finish this one off. And the will is basically to do this. So I filled up one hole with solder. So basically what I can do, oops, let's hope it's not going to make a liar of me here. Like so. Now I just need to get this kind of straight. It's still not straight. Yeah, it's probably a bit more of a pain than doing what I should have done in the first place. And that's soldering these in before the relays went in. But I think you get the general idea. Not quite flush down on the board. Can get enough residual heat just to be able to walk it down. Now, this one here, see how terrible these joints look? The solder just doesn't seem to want to take to the pins. I mean, it is soldered, but it's probably dry as. So I'm just gonna put some flux on all of these actually, just flux them all up. Should hopefully help me to get this right. It still doesn't look right. Alright. Now just these 6-way ones to go in. That bit of the board was hot. That's it. Okay, I'm just going to use some liquid flux along this one, given all the trouble that I had with the last one just not wanting to behave. It's probably because these parts have been rolling around in a box for, however many years this thing has been sitting around unbuilt. Okay, that seems alright. Alright, lucky last. There we go. Again, liquid flux. Okay. Doesn't look too bad. So, here's our leftover parts. The LEDs we're not fitting, the current limiting resistors we're not fitting. There should actually be 5 LEDs, but one of them, well, I'll show you where it is actually. Let me just turn this on. Let me show you where it is. There it is there, in my Tektronix FG501, because the power lid wasn't working, so I stole one of these blue LEDs to so I'd have a power light. So there you go. Right, so we just need to clean this board up now. So I'll just do the initial clean with some isopropyl. when I worked in the factory, we had a PCB washing machine. It basically just looks like a great big dishwasher, and that's effectively what it was. You basically had drawers in there that you'd load your circuit boards in, like, you know, you just load them in just the way you load your dinner plates in. Exactly the same. But obviously you didn't use dishwasher liquid. And yeah, it would do a pretty good job, multi-stage process. I mean, the thing about doing it manually like this is you get these little kind of like blobs of solder, of flux that kind of like get stuck on the edge of pads. And you know, the problem with this sort of mechanical process like what I'm doing here is you can see like there's bits and pieces of solder mask coming off the board, but it's really the only way to do it. I mean, some people, you know, they wouldn't even bother cleaning it. I mean, you see some stuff come out of factories where boards haven't even been cleaned. I think that's pretty poor myself. I personally think that a board should be pretty close to spotless, which this one isn't quite. But we've got the worst of it off now. So I'm just going to finish it off with some of this CO contact cleaner, which is really, really good stuff. It's not actually meant for cleaning a board like this, but gee, it does a good job of it. But it's expensive. I think it's about $30 a tin. So that's why I used the ISO just to get the worst of it off, and then just the final go with this stuff. Okay. Alright, so I think this board is now built. So the next step will be to test it. Okay guys, so this board is in now. At the moment it has nothing on it except for power. Just make sure that the voltage regulator works is the first stage. So basically if I put my probes on here and I turn the output on, I get 12.6 volts on the input. So remember, we have two supplies available, 200 volts DC and 12.6 volts DC, both regulated. The 12.6 is the heater volts, so that's basically what we have available to drive anything. So if I look here, we should have 5 volts DC. So we do have 5 volts DC. So that's the output of the regulator. So that is good. So if we basically, I'll just turn the output off for a second and plug my cable harness in. So theoretically what should happen now is should have relays operating once I turn this on, and we should get LEDs coming on to indicate which input is selected. So let's just turn the output back on. Well, look at that, the DVD LED is on. Let me just bring this down so you can see a little bit better. There we go. DVD, tuner, DAC, CD. And I can hear some relays going as well. So I should be able to measure the relays and check that I actually am getting the contacts. So the output is over here, left out positive. So at the moment we're on DVD. DVD left in is this one. Correct. So if I just check all of the lefts, correct. And left, positive I think is that one. Correct. We check the rights. The right output positive is that one. Correct. Check this one. Correct. That one. Correct. And right. That one. Well, there we go. So that PCB seems to be working as it should, so all we need to do now is to get somehow or other this mess needs to be demessed so that we have all of these inputs coming in here nice and neatly. And the trick will be the ground wiring, because there aren't ground inputs, there's no ground switching on this, it just switches a signal, so you have to wire the ground separately. But there is a ground on input 4 and on the output because it supports balance, so we'll have to sort that out, but that's the next stage. Okay guys, so I've got these input harnesses done. It was really fiddly because I think I mentioned that there's no ground switching on these inputs. There's this one balanced input which has got a ground point, so there's a ground point there and there. On the outputs there's ground points as well, because the output supports a balanced input, which is this one here, but the rest of them are all single-ended and there's no ground connection at all. So basically what I've done is these 3 channels, so you've got left, right, left, right, left, right. The grounds are down here and they're running over here, and then on this channel here the ground is running in here. So on the PCB this point, this point, this point and this point are all ground. So basically I'm commenting out the grounds on the PCB and the outputs will come out on this side. So I haven't wired up the output, as you can see, yet. I've got a problem that I need to resolve with the potentiometer, which is where this output goes to next, and then from the potentiometer it'll go to the preamp board itself. So I just need to resolve that problem with the potentiometer before I can install that. So I'll do that on a later video. I want to wrap this video up, but this gives you the general idea of how this input board is going to work. I hope you've enjoyed this video. If you want to support my content, support my channel, you can do that over at Patreon, patreon.com/AudioNautica. I'm also on Instagram. Please do subscribe to my channel if you haven't already. Give me a thumbs up, and I look forward to seeing you on the next video, and watch out for part 4 of this video series on this Marantz 7C clone build. Bye for now.